first of all, you're welcome to the fourth webinar for African territory. Today, me and my colleague Anil, we will talk about ProtaStructure's advanced analysis techniques, some sample models. He will show some checks from some sophisticated checks from our reports, and of course we will give some clues about the new version, which is ProtaStructure 2024. So as you see, we have an existing building. So what I did first, we created a survey form. Okay, survey form. You can see that we just made some inspections on the building's place, and we just measured, for instance, building height. We checked, is there any structural system irregularities? Of course, we did steel inspections, for instance, rebar diameters, spacings, link diameters, spacings, etc. Is there any, is there confinement, or is there any hook for the stirrups? So we all inspected, actually, we inspected all these informations. And of course, we did some lab tests, and we just determined the concrete strength, existing concrete strength, okay, the average of the existing concrete strength. And of course, we just removed the concrete cover, and we have checked the corrosion level of the structure. For example, there are some minor corrosions at some parts. So I'm going to insert low corrosion for the structure. So before we go further, I would like to show that we created 2D CAD model of the structure. You can see the members' geometrical details, axes, etc. You can also see the sections from the different directions. So what I did here, I just imported this DXF from external reference drawing, and I imported all members from here, such as grids, columns, walls. Then I simply, let's go to the first story. Then I simply tied with beams, inserted my slabs. From loading editor, I added my partition wall loads. Then I just inserted a 4-story, and I copied my story information to the other stories by the generate story command. So simply, I have created my 3D model of the existing project. Then I'm going to go to the analysis and building analysis. We have edit materials tab because as you saw in our test results, we need to insert this existing concrete axial strength in here. So that's why I have created a new concrete class. I have inserted mechanical properties, models of elasticity, I calculated regarding to Eurocode. So then I applied all these material to the all members. For instance, concrete columns, walls, beams, slab, etc. You can also select the, for example, concrete grade from here. Let's say that we don't have any rib on our rebars, so you can select the plain one here. Let's just apply to the all members. So you can also insert your seismic parameters from here. You can insert peak acceleration. Of course, this is valid for Eurocode. If you're using another code, this interface may have some changes, so you just need to insert the seismic parameters from here. Of course, our first analysis should be linear because first we need to insert our existing reinforcement to the members, and to do this we need just a random analysis to be able to insert a reinforcement. I have just skipped model options. By the way, instead of shell wall model, I will use mid-pier model, and it will be much more quick, the analysis, I mean. Now I'm running the analysis, and by the way, I forgot to mention, but of course, the software is supporting two linear analysis seismic load type. So one is equivalent, and the other one is, let me show you, a model analysis, and you can select this from here. Okay, equivalent static load or model response spectrum. Especially if you are using a linear method, you need to select seismic loading from here. Then in the post analysis, we can just click on column wall design, and in here, as you saw in our steel inspections, we need to insert these existing reinforcement patterns to the our members. Let's say, let's just click on it, and for instance, we can just change the rebars regarding to this information. We have 4 intermediate rebars on the Y direction and 2 intermediate bars on the X direction. So I'm going to insert the same. Actually, it's exactly the same. I need to also change the shear design. So again, I'm going to go to the my steel inspection page, and here Phi8 20 centimeter spacing. So I'm going to insert this value in here. You can select the diameter and insert the spacing in here. You need to check this option, by the way. Then you can simply click OK button. Then what I can do, I can copy this information, reinforcement information, to the other columns by paste bars to all. If you want to paste all these bars to the all similar columns, you can use paste bars to all command, or you can simply select other columns and use the paste bars command. Okay, just like this. So this reinforcement information will be copied to the other stories. Of course, you need to do this for a whole columns in our column design interface. But I already did instead of you, so we can skip this part and we can pass to the beam design. I'm going to do the same, exactly the same in here. What I need to do, I need to just play with the reinforcement in here, and then I can simply maybe can remove them. Okay, I'm going to also remove this reinforcement as well. So once I click OK button, existing reinforcement has been inserted to the relevant beam. The design can be cross because it's an existing, actually it's an existing building, an existing actually beam, so it doesn't have to satisfy the design, so it can be just like a red cross. Of course, what I need to do, we can copy bars to the others using paste commands. Okay. So then in the analysis tab, we have existing building assessment button over here. So in here, we can select the pushover analysis. And now the pushover parameters will be loaded soon. Building information level, if we have a blueprint of the member details, reinforcement details, you can select the detailed option, or you can select limited one, or if you select other, you can specify a factor that you can reduce the moment capacity of members. Here we have earthquake levels that represents different return periods. For instance, first one represents the 2475 return period, second one 475, 72, and 43. Of course, these values are calculated regarding to the formulations as it's actually based on statistical parameters, actually formulations. So what I need to do, it's a residential building. So regarding to the 475 return period to DD2 level, the structure should satisfy the life safety performance goal. So that's why I'm going to select the second option. You can also change the load coefficients from here. So what I need to do, I need to insert total number of steps. Of course, you can do some iteration in this case. If there is no convergence error, you can keep this default number. But if you will face with the convergence error, you can increase the total steps in here. So we have different pushover directions. Your structure must satisfy for each direction. And control node, generally, we are taking the top diaphragm node. So that's why I selected this node in here. Target displacement, we have different methods, Eurocode, Turkish code, or FEMA, FEMA 356 you can use. So in here, I'm going to select the Eurocode A, and let's just run the analysis. Now it's force deformation relationships are being determined, and it will take a couple of minutes. By the way, I will take the questions at the end of the session, so don't worry about it. Now the pushover analysis has started, and we are pushing the structure till the target displacement with the lateral load vectors. Okay, as you see, our building doesn't satisfy the performance goals. So you can see the pushover curve, target displacement with our elastic response spectrum. You can see our target displacement. We have detailed results in here. You can see the moment curvature diagrams for each member. And detailed reports, we can prepare the report from here, and you can see the rotational values in here. We have report in here, but this report is valid for Turkish code, so you can simply use detailed reports, and you can just copy and paste to the paste your values. There are a lot of Excel sheets and check the design, actually check the performance goals via this method. But in here we are also providing a report, but this includes some formulations from Turkish code. So as you see, our failure type is ductile. It should be like this because we don't want any brittle member, brittle failure. So if we have any brittle member, we need to retrofit that member. You may use column jacketing, or you can use CFRP in order to satisfy code requirements. So as you see, our model is not satisfying the performance criteria. In order to do this, I did some retrofit. I added some retrofitting members in my model. So let me show you what I did. First, I tried to increase the structural integrity. So that's why I have added a new shear walls, as you can see in here. So these shear walls and that one, let me select all shear walls that I added as a retrofitting shear wall here. So then, and I have also added a column jacketing for this corner column. So first, what I need to do, actually, you can draw this shear wall between the columns, just like me, and you can change the existing reinforcement, existing actually concrete class and steel grade from here. So I have selected C30 for my new retrofitting member, and I have selected grade 500 for the each steel group, longitudinal bar, links, etc. Okay. Then what I did in here, I just selected this all actually shear walls, and I have pasted to the other stories with generate members common. So what I did, I have just selected members. Please note that you need to select this option if there's a existing member in other stories. So you can simply copy to the other stories with this common, is actually retrofitting shear walls. I will show column jacketing in other column. So what we can do, we can just right click, select the column jacket, or we have also button over here, insert column jacket. So you can specify the thickness, for example, 200 millimeter. If you don't have any anchors between or any reinforcement between original column and column jacket, there won't be any transferring. There won't be any moment transferring. So you can select this option. But in my case, I will not. You can select the concrete grade from here, and steel grades must be selected for the new member, just like this. Of course, I'm gonna delete this member, but you need if you copy this to other stories, it's actually deleting the existing members. So I suggest you to add this column jacketing for each story, okay, separated. So then, of course, I need to specify, I need to create reinforcement for these actually new members. For this purpose, I'm going to use the medium ductility level, and I'm gonna run the analysis because we need to specify some reinforcement for these new members. Okay, so now we can go to the design tab and columns. By the way, I added R letter at the end of the shear walls because it will allow me to filter the members quickly. Otherwise, it may be hard to recognize these retrofitting shear walls. Okay, I just selected these 4 retrofitting shear walls, and once I click OK button. By the way, I don't want to filter C1 instead of C12X. This X representation refers that this element, this member is a column jacketing, so that's why it ends with X. Okay. So let's start with the column jacketting's reinforcement. Okay. First, what we can do, we can get into the rebar layout. If you want a single layer reinforcement, you can use automatic containment from here. I'm going to insert corner number 1 for other intermediate rebars, like 5 rebars will be okay. Once I click OK button, of course, there won't be any tie bars, so I'm going to remove them. And just like this, we can add as a single layer, or you can delete all rebars and you can insert stirrups for each zone like this. And then I can add my reinforcement manually. Let me delete bars, and we need to be sure that corner bars 1. Okay. Now I can quickly add my rebars from here. You can simply select an intersection and drag to the actually cursor to the other intersection. It will allow you to insert intermediate rebars just like this. If you want, you can just hover over on it and press delete button to delete the member. If you want to add tie bars, you can simply connect these rebars with your left button of your mouse. Okay. I'm selecting the rebar, pressing my left button on my mouse and dragging to the other rebar just like this. Of course, I will not insert all rebars because I already did in here. So you can see the my reinforcement pattern in here. For shear walls, what you can do, you can play with the rebar numbers from here. Okay. So I click OK button, or you can simply reselect all bars from here. But if you are well experienced, you can just find the appropriate diameter for these shear walls. So we can simply copy and paste to the other shear walls, just like I did in here. If you want, of course, you can just check the steel bar whether it's sufficient or not. Let's do this. Or, by the way, if you want, you can reselect bars from here automatically. And copy this information to the first story because we just canceled the reinforcement in there. So that's why. Okay. So as you see, I have inserted all reinforcements for my shear walls. Then I'm going to go to the analysis once more and click to the existing building assessment in here. This time again, I'm going to select the pushover analysis. Then, of course, by the way, you can use steel bars, approximate steel bars as a percentage. If you don't want to insert steel bars, you can insert minimum values from here as a percentage, as a rebar percentage, and you don't have to insert one by one for the beam members in the beam design. Okay, I will not mention these parameters once more. Again, I'm going to select your code A and run the analysis. One of the limitation is in pushover analysis. The finite element members for shear walls are not supported yet, so you should use the mid-pier model. Actually, it's more sufficient and quick. And we are using the finite length hinge for the end of the members as a plastic hinge for pushover analysis. As you see, now the performance goals are satisfying the code requirements. So what I can do now, I can pass to the detailing part. So I would like to show how I detailed these retrofitting shear wall members. Just for example, you can see that I have just created these details by our actually macro in the design library. You can see that we have retrofit wall. You need to fill all these parameters. I will not spend time for it because it's just you just need to fill relevant parameters. And once you click OK, by the way, you can create such a detail like this. And what I did, I have scaled, and of course, I did some adjustments on it, and also I draw sections just like this as a detail of retrofitting member shear wall actually. What I did also, let me show you. We can open the form plans. I also create hatches on the actually my retrofitting walls, and you can see them, and you can also see these retrofitting walls on sections. Okay, so lastly, I would like to show time history analysis. Let's just get back to the analysis part, and I'm gonna run the time history analysis at this time. So now time history parameters will be loaded in here. These parameters are exactly the same, so I will not mention them. In here, you can add your ground motions. Okay, so once you double click on it, you can add time history data. And if you go to the ProtaStructure folder, okay, we have accelegrams in here, so you can pick anyone in here. You can preview the data. As you see, first 4 lines are just a definition of the accelegrams. And if you want to skip these lines, we have header lines to skip. Okay, so that's why we inserted 4, because we will start directly from the values. Okay. And delta t's, of course, you can play with the delta t values from here. Once you click on the plot time history data, it will be seen in here. Okay, you can do the same for y direction, or you can simply click on the set default accelegrams, and all default accelegrams will be loaded automatically. You can scale. Of course, we need to scale these accelegrams regarding to our response spectrum. So if you want, you can scale this regarding to the average of these actually accelegrams, or you can scale for the each spectrum. Okay, just like this. And you can see that for the each different actually accelegram has been increased with the different scale factors in here. You can also change the output time. So of course it will take a really huge time, so I'm gonna delete the last 10 accelegrams, and I'm gonna use for only first one. And maybe we can increase the time step a bit more, otherwise it will take too much time. Okay, so let's run the analysis. Of course, it will take a bit time. Now the software is preparing the force deformation diagrams, relationships behind this interface. Okay, and you can see the steps that are being used in the time history analysis. So as you see, you can see that performance goals are satisfied after time history analysis. So lastly, I would like to show some projects. You can also go to our website and check the capabilities of the software. Even high-rise structures or complicated projects can be modeled in here. So that's why I suggest you to check these models. I would like to show also different projects from my database. For instance, of course, these models are including a bit more members, so that's why you can see what one of the most reputable companies' headquarters in Turkey. So even it includes steel and concrete members together, and it's been the design has been done together and submitted to authorities by using the ProtaStructure. I'm going to open another model, for example, a campus building. So in here, one of our client has been quickly completed this building using ProtaStructure. So let me show the model. I'm going to open the 3D view. Let me ProtaSteel. So and last one will be also one of the most known banks headquarter in the finance Istanbul Finance Center. So just like this, and it's been quickly. By the way, you can see that you can quickly rotate around the 3D model. There is no lag or any problem while you are just investigating the model. So, and lastly, I would like to show a steel model to show the steel capabilities of the software. Okay. So this actually a tunnel project from the Middle East. Okay, even as you see, there are really complicated lateral braces, or you can see the connections over here. So our client has just submitted raw drawings and it's been approved. You can see the connections. Okay. Base plates. So let's just check the details. Here, for example, we have section details. You can simply create these sections from the grids as a views, and let me turn off this interface. Okay. So as you see, these labels are dynamic. You can place where you want. Okay. And we have just added dimensions. I mean, our client has just added dimensions, and that's all. You can see the just base plate has been hidden in here. Of course, if you want, you can go to the views filter settings, and you can again unhide this base plates from here. Let me show the details. So all these details are precisely prepared by the software. You can see we have splice. Okay, and I'm gonna show the other drawing. Example, 3D view and connection details. We have so many connection components, so that's why it can take a bit time. For instance, we just created detail item manager, like detail item boxes around these connections. And once we click this detail item manager button, all these actually connection details are prepared automatically. Okay, let me show you. You can just add dimensions and that's all. And lastly, maybe I can also show the splice. Okay, so lastly, let's check the plans. You can simply create these views in here and add dimensions, and that's all. Of course, we can export these drawings to the DXF file for the CAD softwares. Okay, so I will just hand over the presentation to Mr. Anil. He will continue with our sophisticated checks in our post-analysis report. Then he will show some clues from our new version, which is ProtaStructure 2024. We have so many new features in there, and I suggest you to definitely attend to our 2024 launch webinar. And I'm handing over to the presentation to the Mr. Anil.
Thank you, Mr. Volkan, for the informative presentation. And welcome all again. My name is Anil Can Gümüştepe. I work as a technical support engineer at Prota Software, and today we have a new building, and we will talk on the seismic, mostly seismic checks that Prota Software, ProtaStructure can do automatically. So I want to start with the strong column weak beam checks. What is strong column weak beam checks is it is the base part of the capacity design. So in an extreme situation, in a network situation, by doing these checks, you ensure that your beams will fail before your columns, so that your columns will carry the building, will prevent the collapse, total collapse. This check is very important for especially earthquake-prone regions. And basically what we do is we compare the moment capacities of columns and beams at each joint in each direction. So it is, as I said, very crucial to prevent total collapse, since the columns are the backbone of the structures. And most of the building codes include these checks. So now I will show you how you can perform this check in ProtaStructure. Before doing this check, you have to do the building analysis, and you have to design your columns and beams in order to software to calculate the moment capacities of these members. For performing the check, you can use the shortcut under the reports, strong column checks shortcut. We have one shortcut here. We have another one in building analysis menu under reports tab, located here. And also we have another one for your convenience in column design interface, which is located here. So let us perform the checks. And as you see, the report pops up, and in this report, on the left-hand side, you can navigate through the notifications. So you can see which columns are sufficient and which columns are insufficient. We can monitor them from here. You can see the calculations, you can see the moment capacities and the relevant ratios, which are tested against the code-based threshold. And also you can use the headings part to navigate through the report. So in addition to the report, we provide a visual inspection in the visual interrogation part. So you can select the strong column weak beam checked here, and the members are colored according to their status in strong column weak beam checked. So red ones are obviously failing, green ones are passing, and the blue ones are the columns that we don't need to do, that we don't need to perform the strong column check. So as you see, we have some members, we have some columns that are not sufficient for strong column checks. So what we can do to satisfy them is, actually we have two main paths to satisfy this check. We can either increase the column capacities, obviously, or we can decrease the beam capacities. But the logical thing here is to increase the column capacities. And in this manner, in this path, we have also two different options. We can either increase the column sizes or we can increase the column reinforcements. The most used method here is to increase the column reinforcements, because we need to obey the architectural drawings. So let me show you how you can do it. And just selecting this C12 column and go to section design. Here I will increase the reinforcements a little bit. You can either increase the number of reinforcements or you can increase the diameter of the reinforcements like this. And at this point, I'm not going to click on interactive design, because if I click it, let me show you, the program will automatically select the adequate, the default reinforcement diameter to obey the location of the rebars, number of rebars, but it will select the smaller reinforcement, which may not be adequate for strong column checks. So I will just increase them again. And as I said, I'm not going to click interactive design button. I will just close this interface with OK button. Then I will go to column design. I will filter for C12 column only. Then I will copy and paste bars, paste the same bars to all of the stories. And then I will quickly check my column designs, and then I will redo the strong column checks. The report again will pop up. Let's close this one. And if you refresh the display using this refresh display button, as you see, this column is now satisfying the strong column checks. So let me do it for C13 column as well. And I will go to section design. I will increase the number of rebars. Click OK. Go to design. Filter for C13. Copy and paste the bars to all of the stories. Then I will quickly check the design and perform the strong column checks again. So as I said, you have different methods to comply this check, but I believe this is the most used one, most preferred method. So let me refresh this display again. And as you see, the column is now satisfying the strong column weak beam checks. I will not go for all the columns, but you see how you can handle this problem. So it is the strong column weak beam checks is a very important check for the beam column structural systems. And as you see from the model, we also have a floor with flat slab. So for this, for flat slab situations and with mat foundations, you need to check your structure, your slabs against punching. So the ProtaStructure can automatically do the punching checks for you. You just go to the relevant story plan and click on the column punching check button here. And let us click the calculate button, and again the punching calculation report will pop up. And I'm just gonna turn it off. And for punching, we draw the punching perimeter on the plan view around the columns, the most critical punching perimeter. So if the punching perimeter is drawn in green color, it means it is okay. It satisfies the punching criteria. But if it is drawn in red color, your column, your slab is not adequate to is not enough for punching. So what you can do to overcome this is you can insert column drop panels from column properties window from here. You can insert column drop panel. You can enter the dimensions of the drop panel and arrange its location. Or basically, you can increase the slab thickness. So for that, I select all of my members in that floor. I go to slab table, and using the columnized edit, I change the thickness of all slabs in one click. So at this step, we need to renew our building analysis. Let me quickly do that. It will take a minute. And after the analysis, we'll go and redo the punching check calculations. Again, the calculation report pop up. And this time, as you see, we have satisfied the punching check for all of our columns at the top story. So you need to do this check for if you have a mat foundation as we have here. Similarly, click on column punching check button and calculate. And as you see, all of the punching parameters will be drawn on the plan view. And also, as you see, we have a failing member for which I'm not going to make it okay. I'm not going to try to make it okay. What you can do is, again, you can increase the slab thickness, or you can make some geometrical changes in the section of this member. You can make it larger or to dissipate the stresses better. So for now, after the punching checks, I want to continue with the post-analysis report, post-analysis checks report. This report is actually very important for in terms of seismic checks, because we provide most of the seismic calculations here regarding to the code-based checks. So similar to the other reports, we have a notification section, notification and heading section on the left-hand side for you to be able to navigate in the calculation report easier. So what we do here, let me go through this report. So we check for soft story irregularity. At first, we compare the relative rates for upper stories. We do it for both X direction and we do it for both Y direction automatically. And at the at the bottom of these tables, we give you a result that if this irregularity exists in your building or not, and you can investigate the calculations. And next up, we perform the mass irregularity check calculations automatically. We compare the masses of the adjacent floors and compare the ratio with the given code-based threshold value. ProtaStructure can do weak story check, which is called interstory strength irregularity check. In this check, what is done here is basically we calculate the vertical shear areas for shear areas for vertical members in a certain story and compare them with the adjacent stories again. Then we compare the ratio between the stories to the given code-based threshold. We also automatically perform torsional flexibility check. In this check, we calculate the maximum and minimum relative story drifts in a certain story, and then we compare maximum to minimum and give you the result. And this ratios also need to be smaller than the given code base value, the threshold value. Again, we do it for both X and Y directions, and we give the outcome of this check. And the next step is the effective mass participation ratio check. So as you are aware, we have two main earthquake load analysis methods. One is equivalent analysis, and the other one is the model response spectrum analysis. So in order to be able to use the model response spectrum analysis, you need to satisfy a certain amount of mass participation ratio. So this will depend on the number of modes you used in the analysis, which can be changed in the seismic parameters tab under analysis. Here you can change the number of vibration modes to consider in the analysis. So according to, as per Eurocode, you have to comply 90% mass participation ratio for each direction. So for this model, for this building, we achieve 90% mass participation in X direction at mode 11. So we need to use at least 11 modes for X direction. Similarly, we reach 90% threshold in Y direction at mode 15. So for this structure, we need to use at least 15 vibration modes to be able to use the model response spectrum analysis in earthquake load analysis. So next up, we check the relative story drifts. We basically compare the relative story drifts between the adjacent stories. We find the relative story, the ratio, and then we compare this ratio with the given code-based threshold value. Again, we do it for X and Y direction separately. And similarly, we do the second order effects requirement check, again for X and Y directions. And this is the member effective section stiffness factors is a rather informative table. In this table, you will see the effective section stiffnesses you have used in the analysis, which can be changed in building analysis menu under model options. You'll see that the effective material and section stiffness factors here, you can edit them. The values here are editable. You can edit them before the analysis and do the building analysis again. And if you open the post-analysis reports, the used values in the analysis will be printed here. And the story masses table is also another informative table, which lists the story masses and story mass moment of inertias. Also, it gives some information regarding the story diagrams that we have used in the analysis. Let me show you. So you can arrange them from the building analysis menu under model options and slab model. So as you see, we have defined rigid diaphragms for first 3 stories, and we do not have a rigid diaphragm definition in the 4th story. So if it is not a rigid diaphragm, then it's a flexible one, since we have slabs. So you can see the related information in the post-analysis checks reports too. And here in this table, you can see the story center of gravities for X and Y directions for each story. Also, another informative table, we list the calculated wind loads for X and Y directions. And similarly, we give you the calculated earthquake loads, again, for each story and for X and Y directions. Also, there is another check. It is not based on building codes or earthquake codes, but we find it very useful. So it's a seismic overturning check. What we do in this check is we just basically take moments according to the corner of your basement, and we compare the driving force, which is the earthquake force, driving overturning force, which is the earthquake force, and compare it with the resisting overturning force, which are mostly the vertical loads, such as the weight of the building and live loads. And we calculate the moments in each direction, in X and Y direction. We list them here, and finally we compare them with a factor of safety of 3. So this check is not compulsory. As I said, you can turn it on or off in the seismic parameters section. And next up is the summary table for structural irregularities. So we list all of the potential structural irregularities and their existence information in the model. So we don't have any irregularities for this model. We have looked at the report, and I have shown you that some of them are, for example, soft stories irregularities calculated by the software, and some of them are not. We haven't seen them in this report. So let's go to the seismic parameters pane once again. Here we have a tab called structural irregularities. So in this tab, all of the possible irregularities are listed. So the ones with gray font, like this one, distortional flexible plan or non-uniform texture mass distribution, these are calculated by the software automatically. ProtaStructure automatically checks for them, and if they exist, it provides the penalties resulted from these irregularities to your model automatically. But for the ones with the black font, you have to specify if they exist or not. So if you have non-compact plan shape in your building, for example, you have to select this option before the analysis, so that during the analysis and after the analysis, in the post-analysis checks, the related penalties will be inserted to your structure. And finally, we have a summary report, which has the main checks, which is also displayed just after the analysis. The small window pops up after the analysis. It is the same as this one. And with that, we have mostly completed. We have completed the code-based checks part. And before concluding the webinar, I would like to talk on the new 2024 version, which will be released very soon. We have been working on the 2024 version for almost a year now. We are constantly improving in terms of technology and capabilities. The 2024 version will be a great improvement on the existing 2022 version, but unfortunately, I will not show the new version today. To not spoil the global launch event, you will have to wait for the global launch event to see the new version in action. Keep following us on social media, follow us on LinkedIn, Twitter, YouTube, Instagram, or Facebook to not miss the announcements related to the global launch event. But today I will discuss some of the new features of 2024 version. Brand new to the 2024 version, the composite slab beam system modeling and design will be included with step-by-step calculation reports, code references, and formulations. You will be able to check for both the construction stage and service stage of the composite construction. Program will automatically calculate the design forces for construction stage and service stage separately, and all of the code compliant checks will be included for both stages. Another important feature will make flat slab and mat foundation design more sophisticated. In the new version, you will be able to define patch reinforcement zones on slabs. So you will be able to locally increase the slab reinforcements around the support parts, around the columns, for example, and you will be able to use the base reinforcements around the span sections. And also with the new version, a complete overhaul to reinforce beam calculation reports will be with you. A brand new step-by-step beam calculation with code references and formulations will be provided. In addition, a new pressed beam member will be included in the new version, so you will be able to model press-stressed beams and check their designs. Also, we have developed the space truss macro, similar to the truss macro and brace macro in steel modeling, which will make your modeling more accurate and faster. And there will be also lots of improvements regarding modeling, loading, and design. So we can expect the release of the 2024 version soon. We are working very hard to make you meet the new version as soon as possible. So wait to hear from us regarding the global launch event. Follow us on social media. We are on LinkedIn, Twitter, Instagram, YouTube, Facebook. And with this, we have completed the webinar series. Thank you for attending the webinars. I hope the series will be helpful.